in one, but don't let that intimidate you because this is pretty easy stuff, okay? We're finally going to look at what a sine and cosine function looks like on the coordinate plane. We've talked about sine and cosine in relationship to the unit circle. Today you're going to see kind of like the sine wave and the cosine wave. Okay, they're both called sinusoidal functions. That's what they're both called. Sine and cosine both are sinusoidal functions. Okay, the main takeaway from all of this stuff in the beginning is let's start by looking at the function sine of theta. Since we know that angle measures in standard position are periodic, that basically just means it's proof that sine function itself is periodic. Okay, it's going to have repeating output waves. So since theta is our input value, we're going to use the horizontal axis for angle measures and the vertical axis for output values. That will make more sense when we get to the bottom of the page, okay? So here what you have is the unit circle, and you've got all the little ordered pairs and the radians all the way around. So like here's pi over 6, and here's the ordered pair that goes with it. And sine of pi over 6 is going to be that y value of the ordered pair, 1/2. So what we're going to do is we're going to fill out this table. And he just kind of stacked them on top of each other just because he didn't have room on the page to go completely horizontal. But just fill out this table here. So sine of pi over 6 is 1/2. And then keep going around the circle. When you get to pi over 3, sine of pi over 3 is root 3 over 2. Sine of pi over 2 is 1. And then we've got root 3 over 2 again, and then 1/2, and then 0. Keep going around the circle. Negative 1/2, negative root 3 over 2, negative 1, negative root 3 over 2 again, negative 1/2 again, and then 0. And you're just going to plot those points. Up there when it said the horizontal axis is your angle measures, just look how this horizontal axis is labeled. Here are your radian measures around the unit circle. And the vertical that's our output values. That's the y coordinate of all of the ordered pairs. So now I want you to plot the point. Pi over 6 is located at 1/2. Just taking values out of that table that we just completed. Pi over 3, if you don't really know where that is, you can kind of skip it for now. If you're like, where in the world is root 3 over 2? Well, just go to the next easiest one. Pi over 2 is located at 1. You want to skip over the root 3 over 2 again, but you're going to go back down to 1/2 at 5 pi over 6. And then you're going to continue decreasing until you get to 0 at the value of pi. And then we're going to dip below the x-axis. Now we're in our negative values. At 7/6 pi, we're at negative 1/2. If you want to skip the next one and go all the way down to negative 1, skip the next one, come back to negative 1/2, and then back to 0. Even skipping those ones that you were kind of uncomfortable graphing, you can see the shape that this takes, okay? So I'm going to zoom in a little bit. I want you to know that we could also put an ordered pair here. What is sine of 0? 0. That's really important because something that you're going to become really comfortable with in this class is the fact that sine curves start on what we call the midline. And we'll define that at the bottom of the page. But the line that kind of just goes right through the middle of this horizontally, it's called the midline. And sine always starts on the midline. And it looks like an S. Sine starts with an S. starts on the midline also starts with the letter S. So that's all going to help you remember the difference between a sine wave and a cosine wave. Okay, so I'm going to zoom back out and we're going to talk about vocab at the bottom of the page. So here's what you just graphed. Let's talk about this vocabulary. Some parts of the graph that you're going to have to be able to pick out from a picture and that you're going to have to be able to find mathematically. And the first thing and the easiest one is probably midline. And if you read, it says midline is halfway between maximum and minimum. So let's just look at this picture over here. And what you'll normally see me do is just draw a dashed line from the midline. In this case, you can just eyeball it and you can tell that the midline is right here. In this picture, the midline is y equals 0. It's the x-axis, essentially, okay? Now, mathematically, if I took this picture away and I just gave you some maximum and minimum values and said find the midline, you would need to find the average. So make a little note over here. I'm just going to put average of maximum and minimum. That's how you find where the midline is. Anything that's in the middle of two things is just the average of those two things. So if I gave you, for instance, the ordered pair of this and said, hey, there's a maximum located here, there's a minimum located at this ordered pair, you could take the y values and just find the average of them to know where the midline is at. You'll see that in a little while. Okay, amplitude is going to be really easy for you. Amplitude is just the distance from the midline to either the tippy top, the maximum, or the midline to the very, very bottom, minimum. So look at your picture. Everything is labeled nice and neat. There's an arrow right here. From the midline at 0 all the way up to the maximum of 1 is 1. The amplitude of this function is 1. That also works if you want to go in this direction from the midline down to the bottom, the minimum. The amplitude is 1. You've already been able to spot, you've had quiz questions and test questions about periods, okay? And in this case, for the pattern to get back to where it started, it takes 2 pi units. It's like going all the way around the unit circle. You start at 0 and you end up at 2 pi with one revolution. So the period of this sine function is 2 pi. I don't really have anything to add on that. That was really pretty easy for you. Now, frequency is going to become important in some later lessons where we start to have more word problems. You're going to have to really understand that, yes, the frequency is just the reciprocal of the period. So if the period is 2 pi, the frequency is just 1 over 2 pi. Reciprocal means you flip the fraction, okay? But what I want you to understand is why. Why is that just the reciprocal? What is the frequency? And here's the definition of frequency. It's the number of cycles per unit of time. Cycles per unit of time. So when you see this fraction, it means this graph goes through one complete cycle and it takes 2 pi units for that to happen. And you can see that in the picture over here. It completes one whole cycle and that takes 2 pi units of time. That's what frequency is. And then just notice that it oscillates, it changes between concave down and concave up. So of course you're going to have questions about concave. Okay, turn the page. I don't have to say a whole lot here. This is going to be just kind of your introduction to cosine as a function. So do the same things, that way I don't have to talk. If you'll fill out the table, graph the points, and then we'll talk about the vocabulary and basically the fact that it's all the same. This is the same exact situation. It's just scooted over a little bit. So now as you go around, you're going to be taking the x values of those ordered pairs on the unit circle. there's my whiteout. Actually, that is actually correct. Sorry, root 3 over 2. And cosine of 0 is 1. So this behaves the same way as a sine function. It is a sinusoidal function. It's just scooted over a little bit. So the great news is the definitions for midline, amplitude, period, and frequency are all the same. Notice cosine does not start, and I use that word kind of flexible here, but it doesn't start on the midline. It starts above the midline. It starts at 1, and then it goes down and then comes back up. It's a smooth curve. Okay? It's a periodic function. But again, we don't have to sit there and talk about all of this stuff because the definitions are still the same. Midline is halfway between max and min. Amplitude is the distance from the midline up and the midline down. The period is still 2 pi. Frequency is still the reciprocal of the period. Still oscillating between concave up and concave down. And everything we need is labeled in the picture here. There's the midline. The amplitude. And the period it takes to start the pattern repeating again is 2. Okay, so that big fancy word sinusoidal functions, it's just involving an additive or multiplicative transformation of, they're all transformations of sine. The sine and cosine functions are both sinusoidal because really all you've done to get cosine is you've scooted everything over pi over 2. It's a horizontal translation of pi over 2. That's all this is saying. So turn the page and let's practice with this vocabulary. Here's a graph. 2 periods of the sinusoidal function are shown. Find the period, frequency, amplitude, and midline. Now, when you have a picture in front of you, it's going to be the easiest thing in the world. So midline, you can actually just eyeball it, is just going to go right through the middle. It's the horizontal that cuts it in half. And usually right over here is where I'm going to label that. Well, that dotted line is at y equals 3. So I just always start with the midline because it's going to end up being probably one of the most important parts of your graph in some later lessons. So the midline is y equals 3. I want you to make a little note. If we didn't have the picture, that would just be the average of the max and the min. And you'll see that down at the bottom of the page on example 3. We don't have a picture, so we're going to have to average the maximum value and the minimum value. Okay, the next, I really think all of these are pretty easy here. What would the amplitude be? 3 all the way up to 6. Amplitude is also 3. Now, here's really how you're going to find it mathematically is, okay, the amplitude is 3. You can take the maximum and subtract your midline. 6 minus 3 is really what we did there to get 3. So if I take the picture away, you can look back and say, how do we do that? It's the maximum value minus the midline value. Okay, easy peasy. Period. If I start here, you're looking for when that pattern starts to repeat itself, which is right here. So what is the period of this function? Now you're looking at your x values to figure out the period, and it's pi, okay? We went through one whole iteration, and it took pi units for that to happen. So the period is pi. Technically what I did is I started on this x value pi, and I subtracted this x value 0. Pi minus 0. So again, I'm telling you all of this because once the picture's taken away, you're going to need a way mathematically to find it. Frequency. So frequency is just the reciprocal of period. So, what's the reciprocal of pi? 1 over pi. But I want you to make a note, again, I want my students to really understand what that's saying, and that just means this function goes through one cycle per pi units. That's what that means. One cycle takes pi units. Yes. Period is just like the horizontal distance before it starts repeating itself. So yeah, I know what you're asking, and yeah, it's kind of the same thing. All right, let's do all of that again. Let's pick up the pace a little bit. See if you can start with the midline. And then the amplitude. Period. So the same way that we've been doing this, to find the period, I'm going to take the larger, I'm going to see when it, like peak to peak, I'm going to take like pi over 2 and subtract 0. And that's just pi over 2. What's the reciprocal of pi over 2? 2 over pi. So here's where I'll start to hopefully make a little bit more sense. Check this out. This is going to run through 2 complete cycles by the time we get to pi. 2 complete cycles, and that took pi units for that to happen. 2 cycles per pi. So Addison, now you see kind of like, it's not necessarily the same thing. Okay, now let's do all of that, but now we don't have a picture. The sinusoidal function has a maximum at pi, 8, and a minimum after The the minimum that basically occurs right after that is 3 pi comma negative 2. So we're going to do all the same stuff. You can start wherever you want. I'm going to just start with the midline because that's what I was doing in the pictures. So when I say maximum and minimum in an ordered pair, what am I talking about? The y values, okay? And your brain should be trained in this class. If you're ever asked for maximum or minimum, you just are talking about the y values, the top and the bottom. So average those two together. 8 plus negative 2, add them together, divide by 2. That's 6 halves. So the midline is at y equals 3. Let's go straight to amplitude. In a picture, you would just kind of count. But now you have to really think. Look at what we wrote up here. You're going to do the maximum value and take away the midline to find the difference. So the maximum value is 8. The midline is 3. So the amplitude would be 5. Okay, now period is a little bit tricky on this one. Think about this. It gives me a maximum and then it gives me a minimum. So like in this situation up here, if I had a maximum and a minimum and I just subtracted, is that one full period? It's half a period. So mathematically, if they give you a maximum and a minimum, go ahead and find the distance between those, but then multiply it by 2 to get your full period length, okay? So here's what we're going to write. We're going to write, look at your x values now. 3 pi minus pi. 3 of something minus 1 of something is 2 of something, so 2 pi. But if you want to draw a quick little picture for yourself, that's just a maximum to a minimum. That's 2 pi units. So then you need to multiply by 2 to get the full period length. So 4 pi is the length of one full cycle. And the frequency is just 1 over that. 1 cycle per 4 pi. So that one's going to be really stretched out because it takes 4 pi units to go through 1 cycle. So see how this one's really squished? That's because it goes through 2 cycles in pi. The one at the bottom of the page is going to be more stretched out and kind of lazy. Okay, we've seen this problem before. Now we're going to add to it. We've got this clock. We're talking about the minute hand. It's 8 inches long. The center of the clock is 120 inches directly above the floor. And the minute hand is 8 inches. At time equals 0, the minute hand is pointed directly up, just like it is in the picture. So at time equals 0, it's the furthest possible distance away from the floor that it could be. Now, the clock's not working properly, and so basically it takes 30 minutes. Instead of a whole hour, it takes 30 minutes for it to go back up to that same position. So one cycle takes 30 minutes. As the minute hand moves, the distance between basically the tip of the minute hand and the floor changes. Okay, we get it. Here's what some of you missed on the test. You didn't really understand that it wants ordered pairs for F, G, J, K, and P. Ordered pairs. Time, comma, distance from floor. It says that right here. H is the height in inches between the minute hand and the floor, and then T is minutes. Okay, so it wants ordered pairs. Well, everybody that came in this morning to look at their free response, and this helps me understand where the misconception is, assumed that right over here was always going to be 0 on the very left. No. And look at what they say. No scale is indicated and no axes are presented. They're telling you don't make any assumptions about where the numbers go. You have to understand in this particular problem, the peak of the graph, the biggest distance from the minute hand to the floor, that actually does start at 0 minutes. And it takes 30 minutes for it to go all the way back up to be its furthest distance from the floor. And then now you're just going to be cutting everything in half. Notice I'm labeling the x-axis with time. So 15 minutes, 7.5, 22.5. This is the same exact problem we saw in the notes in 3.1. The same problem. The y-axis over here, we've got the midline, the maximum, and the minimum. Think of it that way. What's the maximum distance that the tip of the minute hand is from the floor? 128. What's the closest minimum distance that the minute hand will be from the floor? 112. When it's pointed down at the 6, it's going to be 112 inches from the floor. Okay? And then the midline of that is what? 120. When the minute hand is at the 3 or the 9, it's going to be 120 inches from the floor. Now you just put all that together for your ordered pairs. And I like to look at patterns in math. I think it's cool, so I just do, I'll just do my x values first. And then I'll just say, okay, starting at the top, going to the midline, dipping down to the bottom, minimum, back up to the midline, all the way back up to the top. Okay, now that's old news. Today's stuff is find the period, frequency, amplitude, and midline graph. I don't care what order you do it in. The midline's right there in front of us. Amplitude. What's the amplitude? 8. Good. This stuff's pretty easy. Period. 30 minutes, yeah. To go all the way around the clock one time. Well, that's pretty easy, right? Again, this means it takes 30 minutes for one cycle. Okay, lastly, find 2 intervals that the graph is decreasing and concave up. Decreasing and concave up. The first one that I see is from G to J. Here's how we're going to list that interval. Intervals are x values. So I'm going to say 7.5 minutes to 15 minutes. That's an interval. Now you have to think beyond the picture to find another Well, that mirrors itself over here. I just need to know where those are. So where would this one be? All the way up to where? 45. So 37.5 to 45. It's decreasing, and it's also concave up. Okay, one more thing. A lot of you had questions on the test about, there was like a multiple choice kind of embedded in there, and it said, positive or negative. This entire function is positive. Why? Because all of the y values are positive. We're never dipping below the x-axis, okay? So all of this graph is positive. Just wanted to make that clear. Did you have a question? Would F to G work? No. No, because it's concave down from F to G. Right? So we're having to look at concave up portions, which is here to here and here to here, like the smiley face parts. But it also wants decreasing, so only the left half of the smiley face. This would be increasing in concave up. This is decreasing in concave down. Yes. At the point of inflection, which would typically be G and K. So that's the second it changes from a frowny face to a smiley face, right there. That's a point of inflection. Oh, great questions. Can you think of anything else? Okay, you guys did great.